Thank you for coming. I will talk about 3D planning design system because as a planner, we need tools and data to help plan to make Hong Kong a smart, green, and resilient city. First of all, remember last year we have a number of typhoons, right? I met a Singaporean lady. She is the CEO of a private development company in Singapore. It's one of the biggest in Singapore. She told me an experience in Hong Kong a few years ago. She lived in a hotel in Central, but she has a meeting in ICC, Ritz-Carlton. But it's typhoon number 8. So if you go in Singapore, usually every afternoon there are showers, okay? Heavy rainfall. So, but you go to Hong Kong, you bring an umbrella. But we suddenly realized that in Hong Kong, typhoon number 8 was up, and so no business. But she has a business meeting in Ritz-Carlton. So she was impressed. One thing is that she didn't need to use her umbrella. Go from a hotel in Central and travel from the MTR and go to a meeting in Ritz-Carlton and come back without using an umbrella. I just wonder, thanks to our engineers, our architects, surveyors, development industries practitioners, that we help build such a smart, green, and resilient city in Hong Kong. But when we look ahead, we have a lot of challenges. So think about typhoon number 10 last year. We had a lot of problems, but still we're working quite good. But it's only the aftermath. How can we tackle it? So we need the right tool. As a planner, we have to face a lot of challenges. So I'll get you through how can we use different techniques, including BIM, to help plan our cities. Okay, acknowledgements, there are some authorities and departments and the private sector give them information for us to help build this system. This is an internal system so far. Okay, let's look at the challenge detailedly. So we have an aging population, what we call, we are facing a triple aging problem, okay? Aging population, aging infrastructure, and aging building stock. So think about our MTR, when it was built, the Kwun Tong line. And also think about the density in Hong Kong. Think about Mong Kok. Think about Tsim Shan. If you look at history, Tsim Shan used to have about 130,000 people. Okay, Ada is here. Housing department have built a lot of public housing estate. But Tsim Shan was used to have 130,000 people about 20 years ago. In the West, it's a city already. Okay, nowadays we need more land to help to build more public housing, and we need land to build our private sector. And also, a lot of things, challenges. We need economic land. So, when you translate these challenges into something that we need to help address is climate change. How can we build a resilient city, okay? We need to find economic land to house our next generation industries. So we need to find economic land to help build our science park, industries, and also research institutes, so that we have embraced our next stage knowledge industry. Okay, so think about Hong Kong. How can we enjoy a smart, green, and resilient city? But in the development field, you're an architect, a planner, you face this thing. Think about ICC again. It is a vertical city, what we call. So in the basement, you have the high-speed rail train terminal, bus terminus, and also MTR, and also cross-boundary tourist bus. And also on top of it, you have a big shopping mall element. But in between, you have a Grade A office and Sky 100, and on top of it, you have the hotel. So we have a compact city, but going back together, if a compact city, look at this chart, this one, oops. We have high density, but is it livable? think about the density here. Hong Kong is here. But think about in terms of livability, Hong Kong is lag behind those leaders like Singapore, Vienna, and also Vancouver. So we have successful in terms of efficiency, but in terms of quality of living, quality of working, quality of leisure, we may not be the good one. So we are facing a lot of things like that. In terms of data, think about GIS, point line polygon. Can you model this one using traditional point line polygon? You're using CAD and BIM, you have facing another problems in terms of data and resources. So I call it is that we have a very complex urban system. So, and also we have a very complex urban informatics. So think about this one. Now, in terms of BIM, you have a lot of groups here. You know what they are. But you have Revit, you have ArchiCAD, you have Bandit system, or might be some of you are using CATIA. In terms of GIS, we have S3's ArcGIS, but we also have SuperMap and QGIS. And also we have a lot of scientific modeling. So we have a complex matrix of all this system when you do a development. So it translated into something more specific. You can see here, we have to make use of different technologies to help plan from a premises space to a building, to a neighborhood, the whole Hong Kong, even cross boundary. Nowadays, we're talking Big Bay Area, right? So we need all those information, all those technology to help us to help plan and develop this smart city. So look at this one. Okay, from the traditional method, when I was a planning student, when I was an assistant architect, a planner, I used to make models, cross-section, all this. Okay, when the digital age comes, just a quiz. Who knows this one? Anyone? We used to make physical model and photo montage. It is, I met Thompson here, okay? Intergraphs, it is about 30 years ago. So Intergraphs model view. We used photo montage to model our city. And this animation was done before the cable car was built. We simulate how the alignment of the cable car interact with Dongchong, and also how we plan the terminus of both ends. And also at that time, a lot of debate where we should put them, which gondola we should use. It is about more than 10 years ago. Oh, sorry. And this animation for the, sorry, there's some technical problem. For animation for the Kai Chiu Do, it is about 10 years ago. But now it's different. This is next to the Causeway Bay. So this is a traditional tool we use. And we have used another system, free design, about 10 years ago. Okay, now we have a planning system in February 2018. So we have, because we need something that integrate everything together. Because when you do different things, you have CAD, BIM, GIS, remote sensing, scientific modeling, impact analysis. We have different tools, but we can't put it together. So what we did is put everything together to share application, to share information. Okay, so the policy is to have a smart government, and also we need data and one-stop web platform. Okay, so first thing, data. We used to have 2.5D model, and also different CAD system. So we use an oblique photogrammetry technique using 5 cameras, 12 camera mounted on a helicopter to capture the information from the both sides of Victoria Harbour. So this technique is like that. So there's a 5 camera mount on the airplane and take 5 shots or 12 shots together. And at the back end, we capture all those data. So you can see the data size, the raw data is about 45 terabytes already. So we use an oblique photogrammetry technique to help build those 3D models. And we built 3D mesh model, converted into about 320 gigabyte. Okay, so let's move on quicker and see the results. Okay, so we have the data, we have analysis and visualization. Okay, let me go through to it. This is the system. 3D photo mesh for Hong Kong, Kowloon, and also in the territories. A web-based integrated 3D platform. So every building is 3D. Now this is the helicopter that do the data capture. The flying house about 2,000 feet above ground. The data capture is only about a few weeks only. It was captured the Kowloon side in 2018, Hong Kong side in 2017. So after we package everything and put it together. So the system, we have planning information. With a click of the button, you can pull out the OZP within it and check the site, which column 1 and column 2 use. What are the restrictions? You can check it. And also you can check the town planning board paper. What are the applicants you guys are submitted to the town planning board? Okay, we have existing buildings. So how about those committed? We translate some approved schemes, whether it's BIM or CAD, into a right format and put it together. So it is one of the approved schemes next to Hub War Center. Another case, we use this system to input those approved scheme, like this is another residential development, a proposed one on Hong Kong side. And also we put down other social economic things like the monument buildings and the cadastral information, the private lot information into it. And also we put our population projection information onto it. So you can see like Wan Chai, this is the Canadian population overall in 10 years' time. But the aged population in the 10 years' time will be increased. So 10 years' time, more aged people in Wan Chai. So if an architect and planner, what are you going to do? And also we put our environmental data into it. It's MM5. With a click of the button, you can check it and also check the expert evaluation report. You find the restrictions on the winds and on the breezeway of that particular site. And also we pull our remote sensing data in. This is the spot near-infrared information. Now, the most important is this one. We have put our BPR into the system. So as a planner, you can check the existing building height of the site and space between buildings because it's 3D. And you can answer a few questions, say like plot ratios, site coverage, average flat size, and you can select the generic building type like Trident, like cruciform. And also you can graphically check it. Then the system will help build different scenarios, like a single block or twin block. And you can compare like to like, which one is better. After that, you can conduct some urban design analysis, like indivisibility, say from the nearby building. And also you can, from a pedestrian view, to have the view shed analysis. The red one is going to block the view. And also you can check the sunlight and shadow. If you're a landscape architect, then you can help plan a landscape or put your land resources there. And also you can check the sunlight. And flood analysis, like Lei Yun Mun is a black spot for flooding. And also you can check whether a proposed building will reach over the ridge line and the skyline through the predefined vantage point. And those architects, you know that we used to use fisheye lens to check the wheelshare and sky wheel factor. Then you can compare different options quantitatively. Now this is a fictitious BIM building. Because we have a lot of development from the private sector's consultant, we input into our system and check the performance. Sometimes we will need to check maybe a premises space. How can the view from an apartment towards, say, across the harbor, on the other side of the Victoria Harbor. This is EMSD's headquarters, the proposed one. So we inputted the BIM model into it and checked its relationship with the surroundings. And also we can click to a certain, like the CCTV, you can pull out the information from that. Apart from BIM, we also interact with CAD, like 3D Studio Max. This is the proposed waterfront promenade design. And all UAS, a manned aerial system like drones. And CFD results. Now, I just want to focus on this is what we have done already. It is so far an internal system. We're going to scale it up because planning is only what we call a continuous process. We need to interact with different departments, different professionals, and different people. So we're going to scale this up to build what we call a common spatial data infrastructure, built environment application platform. Because when you look at this one, we have different players. We have different systems. You might have using different technology, or I said complex urban informatics. So this is the conceptual framework. This is the data sharing part. This is the application sharing part. So what we are going to do, it takes some time to fully develop the system. But in the meantime, we'll open up those 3D data for the public to use. So feel free to go to our Plandy's website to download and use our 3D data, what I've just said, the Hong Kong side and Kowloon side. Every month we will chunk out a certain data set according to this timetable. So the next step forward. So we will share this application with development, the government department within the Development Bureau. And next phase, we will other government departments. And later on, we will scale up for the public, academia, and the public use. So I think this is most important of all. This is a collaborative platform because we call it an ecosystem. Sometimes I'm a consumer. Sometimes I'm a producer. I need your data. Sometimes I need your result. So we need to have all walks of life from your different profession to contribute to application and data. So we can join hands to help build this one. Not only just BIM, CAD, GIS, remote sensing, on other transport modeling results, simulations, more so. So this is our 3D system, and we hope that very soon we can open up this system for everyone to use. Thank you.